I'm Andy, welcome to Narcolepsy Pumpkin. If you haven't done already, why not? Click on subscribe, click on the bell. That way you'll get notifications about new videos when I post them. This episode I'm going to talk a little bit more about testing objects and what they are, how they should be used, and particularly how long they should live, or what the scenarios are, and what their reuse could be. As a rule of thumb, stubs are generally reusable because they're just enough to stop the code throwing an exception, and they're returning generic static values rather than actually anything meaningful. And they're not providing anything that's fitting to any particular scenario. They are simply there as a dependency to stop something that you're not necessarily testing in this test from throwing an error when you pass through the code. If you're using a lot of stubs, as I've said before, this might suggest that you've got some coupling that could be undone, i.e. you're depending on things in a particular code path that aren't actually used. Fakes are often also reusable in that they are just that, a fake. They will react and behave exactly the same as the real thing. Now, given that, what you should be able to do with any fake is, if you've got unit tests that test the behavior of the real thing, those unit tests should run and pass against the fake in exactly the same way as they would against the live implementation. I'm not suggesting that you do this in your code, i.e. run the test against the fake. But that's the principle. They behave and react in the same way as the real thing. However, their underlying implementation details are done quick, dirty, just enough to get the job done. They're not designed for 3 million users to connect. They are just a basic behavioral fake of the real thing. In contrast to those two types of object that are reusable, i.e. fakes and stubs, mocks are generally not reusable because they are pandering to a particular scenario, i.e. they are preloaded to return particular responses that are specific to a test scenario. Therefore, mocks would tend to go with individual tests. So you'd have a lot of mocks within your test suite if you're trying to set up or preload particular scenarios in your tests. So for instance, if you were using a fake to do the same kind of thing, you might have to go through many calls to that fake to get it into a state where you can then test the thing you want to test. A mock allows you to preload that state to allow you to specifically test a scenario. This is done to speed up testing. And what I would say is caution. Using test objects like fakes, stubs and mocks means that your tests aren't using the real thing. There's no reason why you can't use the real thing during tests, as long as you can isolate those things for the test. You can test with real SQL databases as long as you can isolate what's happening in your test from external influence and any other tests. The more of the real things you test with, the better your tests actually are. Use the mocks in scenarios where the real thing for that particular part is either untestable, so expensive that you can't use the real thing, or is so weird, wonderful, specific to some other external thing like hardware that you wouldn't have during the unit tests that it makes no sense to use it. So what I'm saying is, as long as the context is free from external influence and there is no performance issue, a test substitute object isn't a requirement It's a preference. But don't take that as an argument against test objects. It's not. Test objects or test implementations are very useful. However, as with many things, their overuse is just as damaging as their underuse. Creating really slow tests that use no mocks will cause the test to be seldom run, reducing their availability because nobody's running them. Nobody's using the outputs of those tests to assert or check anything. On the flip side of that, tests that use excessive numbers of fake objects, mocks and stubs can become so complicated that understanding what they're testing is so difficult that they fall into disrepair and again don't get run. In these cases, sometimes this is worse than having no tests at all. Tests that nobody understands or is willing to look at change are really not adding value to the code. Finding the balance between test implementations and the real implementations in any given system comes with experience. And experience, as with any profession or vocation, comes with practice, and practice comes only with many mistakes. The trick is to practice and fail on smaller scale or within a much lower risk environment. The easiest way to practice in a low risk environment is by completing code challenges, katas, redoing the same thing and again to assert your approach is correct or valid. This is why I've done quite a lot of coding examples of changing things, refactoring, adding tests, because these are the things that are important certainly when working with legacy code and when writing new code. So having katas for test-driven development, katas for refactoring are important. And these are things you should think about using on a regular basis to hone your skills. Now, many of you are probably now saying, but I don't have time to sit and write code that I'm going to throw away. My job, my time is precious. And I agree, it is. Doing these things can often save you time, but my advice would be time box them. You've got to remember when you're doing katas or refactoring challenges that actually the goal is not completing the challenge or completing the kata. It's the act of participating in the things you need to do. So if you time box 1 hour a week, 1 hour a day, but you keep it at an hour, some might actually have a little bit of leeway in that, so you spend no less than an hour doing it, but spend no more than 2 hours doing it, for instance. This means you work on some piece of code, some challenge, a kata, for that time boxed period. And when that time box is over, you stop. The next time you come to it, you don't pick up where you left off. You start again. This allows you to hone the things that you're doing. You will slowly get quicker and quicker, meaning that you'll get through more during that time boxed period. Obviously that depends on the size and complexity of the challenge, but as you get better you can pick up bigger challenges, move on to hone your skills further. But getting into the habit of doing that on a regular basis is the difficult bit. There is also an inherent thing in most developers' brains that they have to complete something, which is the other difficult thing. Stopping at that end of your time box, only spending a set amount of time rather than aiming to complete the task. task. This then maps into your daily routines, which means you'll probably be able to get to a point in your daily work where you can stop before it's finished. This is certainly helped by practices such as test-driven development that allow you to easily kind of save your state. You're either in a position where you've got a failing test that you need to make pass, or you've got a nice set of passing tests and an idea of what your next one should be. That means you can stop your day at 5, 5:30, 3:30, whenever you have to stop, to transition into family time. Go home, read a book, work on the sculpture you've got in the garage, go and tinker with your car, your motorcycle. Do the things that are of value to you. Don't fall into the trap of sitting at your desk till 2 a.m. just to complete the thing that you started. You will often find that this reaps benefits in coming back to something in the morning. You'll complete what would have taken you hours in the evening in a matter of minutes. Hopefully that's giving you a little bit of insight into what test objects should be used for, when you should use them, when you should probably think hard about whether you should use them, and how you can hone your skills as a developer in general by boxing a bit of time off every week, every day, to repeat katas and challenges so you get better at the things you need to get better at, rather than getting better at debugging, which is not the goal.